Alright, so we are in section 5 of our unit. So section 5 talks about compound statements. And by the end of this session, you should be able to construct conjunction, disjunctions, and implications of simple statements. Conjunction. Suppose we have statements P S is greater than or equal to 1 and Q S is less or equal to 5. We can combine these two statements using the operator AND to obtain P and Q. That is, S is greater or equal to 1 and S is less or equal to 5. This combination is written in the form of S lies between 1 and 5. So S is greater or equal to 1 but less or equal to and less or equal to 5. Thus, P and Q is called the conjunction of P and Q. P and Q, which is 1, S between 1 and 5, is called the conjunction of P and Q. Symbolically, the conjunction of P and Q is denoted by P, and this is the symbol for and Q. The compound statement has become P and Q is that. So this how you express it. Let's take a question. Combine each of the following pairs of simple statements using AND. Kojo is a good boy. Kojo is in the mathematics club. So the solution will be Kojo is a good boy and Kojo is in the mathematics club. Or Kojo is a good boy and he is in the mathematics club. So that's the AND and the AND. S is less or equal. S is less than 9. Q is S is greater or equal to 5. So if you combine this, you are going to have S is greater or equal to 5 and less than 9. So that's how you combine them. Now, next one is 18 is divisible by 3 and 18 is divisible by 9. So you combine them by saying that 18 is divisible by 3 and 9. Again, we have another one. The P2 is less than 9. Q 9 is less than 2 plus 7. So the compound statement is written as P and Q is 2 is less than 7 and 9 is greater than 2 plus 5. So you can also let our students know that the statement P is true statement and the statement Q is also true. Let them also observe that the compound statement P and Q is also true. So similarly, P belongs to odd numbers. Q belongs to P 5 belongs to odd numbers. Q 5 belongs to prime numbers. These statements are both true. So the compound statement becomes 5 belongs to odd numbers and 5 belongs to prime numbers. That is, 5 is an odd number and also a prime number. So you can guide your students to draw a conclusion that in general, if P and Q are both true statements, then the compound statement is also a true statement. Question. Form a compound statement from each of the following pairs of statements using AND. State whether the compound statement is true or false. The first one is 7 is divisible by 3. 7 is an odd number. So how do you combine this one? So 7 is divisible. So P and Q become 7 is divisible by 3 and 7 is an odd number. Since statement P is false, 7 is not divisible by 3. So since statement P is false, the compound statement P and Q is also false. Using the Venn diagram, we can say universal become our whole numbers. A is numbers divisible by 3, and B is odd numbers. So we realize that in this case, 7 does not belong to A. It's not divisible by 3. But 7 is an odd number. So 7 is here, an odd number. B is a set of odd numbers. Hence our statement A intersection A and B, that's the A intersection B, that is P and Q, is not true. Because 7 is not divisible by 3 and 7 at the same time being an odd number. For odd number is true, but for divisible by 3 is not true. So therefore, our statement or our compound statement becomes a false statement. So the next question, P and Q become 2 is between, so S is between 2 and 4. Or S is greater than 2 and S is less than 4. And this is even. The statement is false because if S is a number between 2 and 4, then it cannot be even. Rather, 3 is between 2 and 4. And this 3 is not even number. Observe that the only whole number between 2 and 4 is 3, which is not even. Also, if S is even, then it cannot be between 2 and 4. Then our next, the last one, 64 log 2, log 64 base 2 is equal to 6. And tan 45 degrees is equal to root 2 over 2. This statement is false since Q, that's Q tan 45 degrees, is not equal to root 2 over 2. This is a false statement. So in general, the compound statement P and Q is false if one of the statements P or Q is false or both are false. So even if one of the statements is false, then the statement is a false statement. So for a statement to become a true statement, both should be true. Then we have disjunction, or explain to your students that compound statements that are formed by using the operator or and either or are called disjoints or disjunctions. Symbolically, look at the disjunction symbol, look like the opposite of the conjunction. So suppose P, or our P statement is 2 is a prime number and Q is even. We form the compound statement by saying P or Q. That's P or Q. So in this case, the statement P or Q is true statement. Look at it. The P is a prime number and Q 2 is even. In this case, both statements are true. So therefore, it's a true statement. Now, when we consider this one, S is less than 7. 9 is greater than, so S is greater than 9. So the compound statement becomes P or Q become S is less than 7 or S is greater than 9. We can interpret this statement as either the statement P is true or the statement Q is true, or both statements P and Q are true. So you observe that the compound statement will be true even if one of the statements P or Q is false. Because this one we are saying this or that. So even if one is true, then our statement is a true statement. That is, if S, yes, so in general, the compound statement P or Q is true if at least one of the statements is true. This is what we just talked about. That is, if P is true but Q is false, then P or Q is also true. So if P is true and Q is also false, then the statement is true. If P is true and Q is true, then our statement is true. So if any of them is true and any of them is false, so the statement is true. If both of them are true, the statement is true. If both of them are false, then the statement is a false statement. So you can form the sum of them here, determine whether they are true or false. Prime numbers are easily divisible by 3. 28 is a multiple of 7. So let's look at this one. Prime numbers are divisible by 3, or 28 is a multiple of 7. The statement prime numbers are divisible by 3 is a false statement, but the statement 28 is a multiple of 7 is true. Hence, the compound statement P or Q is a true. Yeah. So the second question is that a rectangle is a quadrilateral, or rhombus is a quadrilateral. So realize that in this case, P is true, Q is also true. So both statements are true. So therefore, our compound statement is true. Third one, natural numbers are subsets of integers, or real numbers are subsets of rational numbers. So realize that real numbers are not subsets of rational numbers. So therefore, both though the first statement is true, but the Q statement, as the second statement, is false. Therefore, our compound statement is also true statement, because though one side is true and the other side is false, we are saying even if one side is true and the other side is false, the compound statement is still a true statement. The last one, either a whole number is divisible by 5 or 2 exponent 3 is equal to 6. First one, 2 exponent 3 is not 6, it's 8. And either a whole number is divisible by 5. It's not all whole numbers that are divisible by 5. Some are. Hence, the compound statement is also a false statement, because not every whole number is divisible by 5. And the Q statement is also a false statement. So therefore, the compound statement becomes a false statement. Implication. One other way of combining simple statement is by the use of if. If this, then that. So that's implication. Now let's consider the some statement. S belongs to factors of 8. Then S belongs to factors of 24. We can combine this statement using if this, then that. That is, if S belongs to factors of 8, then S is a factor of 24. This means that if S is a factor of 8, then it's also a factor of 24. Symbolically, we write this one as P implies Q and read as P implies Q. Implications are also referred to as conditional statements. So we have some few questions there. We want to finish and illustrate them in the Venn diagram. S. S is a Ghanaian. Q speaks Ghanaian language. So if S is a Ghanaian, then S speaks a Ghanaian language. This implies that not all Ghanaians speak a Ghanaian language. Hence, P implying Q is a false statement. Not all Ghanaians speak. So the moment you say S is a Ghanaian, then automatically you speak the Ghanaian language. No, it's not true. The next statement is S belongs to 2, 4, 6, 8. Q, S is divisible by 2. So look at all this, and rather they are all divisible by 2. So we are going there too. We're going to look at this in the next slide. The next one is if a number is divisible by 3, then it's divisible by because time is not an answer. Let's move on to so we can go through some of these ones, then we compare it to the general ones that we've done already. So let's quickly come to converse. Also, all these are the parts of the examples that we have talked about. So in general, the implication P is false only when P is true and Q is false. So we come to converse of implication. We will now discuss the reverse implication. give implications P implying Q, the reverse implication is that Q is a converse of P, and this is called the converse of implication, P implying Q. For example, suppose S is composite number and Q S has more than 2 factors, then we form a conditional statement. So if our conditional statement P implying Q is if S is a composite number, then it has more than 2 factors. The converse of this P implying Q is that Q is a converse of P. If S has more than 2 factors, then it is a composite number. You notice from this particular case that implication P implying Q and its converse Q being converse of P are both true statements. If P implying Q and its converse Q being converse of P are both true, we say that the statements P and Q are equivalent. So symbolically, this is how we write equivalent for statements. Equivalent statement, this is how we write them in mathematics. So this ends the session, and we have looked at so many things in this session. Thank you.